looking at the equation, f of x equals sine x to the fourth power, we can see that we have the sine of x, which we know that one of the Maclaurin series is sine of x equals the sum of n equals 0 to infinity, negative 1n, x to the 2n plus 1 over 2n plus 1 factorial. Now looking at this, we can apply it to this, but we have to plug into the x to the fourth. So, after doing so, we end up with the sum of n equals 0 to infinity, negative 1n, x to the n8 plus 4, after you distribute the 4 through the 2n plus 1, over 2n plus 1 factorial. Now we still have to find its radius of convergence, so we use the ratio test, which we know is the limit, as n approaches infinity, absolute value of an plus 1 over an. Now doing this, we wind up with the limit as n approaches infinity, absolute value of negative 1n plus 1, x to the 8n plus 12, after you distribute the 8 and add the 4 to it, over 2n plus 3 factorial times 2n plus 1 factorial over negative 1n, negative 1 to the power of n, times x to 8n plus 4. Now, after we after the absolute values take care of the negative ones, we have to expand upon this so that way we can look for stuff to cancel out. I expanded this out to make it a little bit clearer, so that way you can see that you can cancel the 2n plus 1 factorials, the x to the 8n's, and 4 of the x's left over. And you're left with limit as n approaches infinity, x to the 8th, 2n plus 3 over times 2n plus 2. In doing that, you can plug in infinity, and we know that if infinity is on the bottom, we get 0, and 0 is less than 1. We know if we get 0 for this, our radius of convergence is infinity. And there you have it.